Hey all, today we're going to talk about some different types of statements. We've been talking about conditional statements, and today we're going to talk about compound statements. So there's a few new symbols to learn. So here we have a P and a Q, just like we've had recently. I made P, it is hot outside, Q, you eat ice cream. And one of our new symbols is the word and. And is this, it looks almost like an A, just without the horizontal bar. And so this symbol in logic means and. So if we want to use P and Q to write this symbolic statement into words, we would say, it is hot outside and you eat ice cream. So notice there's no if-then here with an and type of statement. The V means or. And so whenever we see that V, we use the word or. So this looks like it is hot outside, or you eat ice cream. The last symbol is the double arrow, and that means if and only if. So two arrows, two ifs. Before we had one arrow, and that was if then. So this if and only if, just like and or, goes between the two statements. So if we want to do P if and only if Q, we would say, it is hot outside if and only if you eat ice cream. So let's use these symbols a couple times. I'll give you a new P and Q, and we can translate these just like we have before when we were doing if-then statements, conditional statements. So here I have P. The symbol means and, not Q. So we need to change the meaning of it is the weekend. So we would say it is Tuesday and it is not the weekend. You might say it is Tuesday and it is a weekday. Here we have Q and P, and in between is or. So we would say it is the weekend or it is Tuesday. And last, the double arrow means if and only if. We would say it is Tuesday if and only if it is the weekend. So we really now want to talk about biconditional statements more than what we just did. And a biconditional statement is a statement that has that if and only if in it. And more specifically, it's a combination of a conditional statement, an if-then statement, and its converse. So if we have a conditional statement and we write its converse and we say that both of them are true, then we can write this biconditional statement, a statement that has the if and only if between the P and Q. So let's look at this conditional statement and we'll write the converse. If a shape is a triangle, then the shape has three sides. So let's write the converse by switching P and Q and say if the shape has three sides, then the shape is a triangle. So let's look at the green statement again. If a shape is in a triangle, then the shape has three sides. Well, I think we can all agree that that is true. The converse, if the shape has three sides, then the shape is a triangle. That's also true. No matter which way you say it, the original conditional in green or the converse in blue, both of those things are true, so we can just put them together and write a biconditional statement using that if and only if. A shape is a triangle, if and only if the shape has three sides. Notice there's no if-then now. All we do is take P and Q and put if and only if between them. So let's try a couple more. Let's see if we can write the biconditional by writing a converse and seeing if it's true and if the conditional is true. So here we have our P, a shape is a square, and our Q, the shape has four sides. So to write the converse, we switch those two things. If a shape has four sides, then the shape is a square. So let's see if they're true. If a shape is a square, then the shape has four sides. That's true. If a shape has 4 sides, then the shape is a square. Well, that's not always true. We can create a counterexample to say, well, a rectangle has 4 sides. A rectangle is not a square. Or a trapezoid has 4 sides. A trapezoid is not a square. So in this case, we're not allowed to write a biconditional because the converse is not true, and even though the original conditional is true. Let's try another one. If a number is even, then you can divide it by 2. So a number is even as P. You can divide it by 2 as Q. Let's switch those two to write the converse. If you can divide it by 2, then a number is even. And both of those statements are true. If a number is even, then you can divide it by 2. And also, if you can divide a number by 2, then it's even. Both of those are true. So we can write this biconditional. A number is even if and only if you can divide it by 2. And let me point out again, I have my P, a number is even. I have my Q, you can divide it by 2. Oops, and I did those backwards on you, so this should be green. And this one should be yellow. Just want to be consistent. Okay, now you guys are going to make fun of me because I screwed that up again. I had it right the first time. Sorry about that. So anyways, let me go back through that again since I had my colors wrong, or correct, and then I made them wrong. If a number is even, then you can divide it by 2. That is true. If you can divide it by 2, then a number is even. That's also true. So this conditional and its converse are true. So the biconditional can be written. And all we do is take P and Q and connect them using if and only if. Sorry about that mistake. So here's when I want you to pause the lesson. For sure, pause it right now. And I want you to try these two problems. Write the converse for each of them. And if the conditional statement and the converse are both true, write the biconditional statement, the if and only if statement. So here, if it is September as P, you are in school as Q, so we'll switch those to get the converse. And I'm going to stop playing with the colors now so I don't make a mistake again. The converse is if you are in school, then it is September. So if it is September, then you are in school. That is true. If you are in school, then it is September. That's not always true. We can think of a counterexample. Like it could be October or November or any of the other months where you go to school. So we cannot write the biconditional. Number 2, if a number ends in 0, then you can divide it by 10. We'll write the converse. If you can divide it by 10, then the number ends in 0. If a number ends in 0, then you can definitely divide it by 10. And if you can divide a number by 10, then it definitely ends in 0. And so both of these are true. And so we can write our biconditional. A number ends in 10, or in 0, if and only if you can divide it by 10. So that's it for this lesson. Make sure you answer the few questions that I attached for you. And if you have questions, please ask them in class. Write them down now so you don't forget.